7.1, we're given that asking the question, is the YTM on the bond same as the required return? Is the YTM same as the coupon rate? And third, suppose a 10% coupon bond sells at par value. 2 years from now, the required return on the same bond is 8%. What is the coupon rate now, and what is the YTM? Our equation is the price of the bond, or present value of the bond, is the present value of the coupons, and the present value of the face. Now, the present value of the coupons, to calculate the price of the bond, you take C times 1 minus 1 over 1 plus R to the T, all of that over R. We recognize that from Chapter 6. That is the present value of an annuity. And then present value of the face is face value, or future value, over 1 plus R to the T. And we recognize this from Chapter 5, lump sum present value. Also, we're going to use this equation. Coupon rate is the annual coupon divided by the bond face value, which is usually, for corporate bonds, $1,000. So let's take these questions one at a time. Is the YTM on the bond the same as the required return? And the answer is yes. We know that YTM is little r. There are 3 little r's in that equation, and that's what we're solving for. Is the yield to maturity the same as YTM? Yes, it's the rate required by all other bonds in the market. Is the YTM the same as the coupon rate? And the answer to that is no, because the coupon rate is the coupon rate on our bond. Coupon rate is our annual coupon C divided by bond face value, usually $1,000. So YTM is the rate required by all other bonds in the market. Coupon rate is the rate on our bond that we're holding. That's a key distinction. Once you learn that, you learn a lot about bonds. Finally, suppose a 10% coupon bond sells at par value. 2 years from now, the required return on the bond is 8%. What is the coupon rate now, and what is the YTM? Well, if you're holding a 10% coupon bond, and it's a 30-year bond, that 10% or $100 coupon will pay out every year for 30 years. That will never change. So the coupon rate is still 10%, is the answer to that one. And what is that's the coupon rate at that point. Then what is the YTM? Well, the YTM, required rate of return by all of the bonds in the market, has now gone down to 8. So the answer to that is the YTM is now 8%. There are your answers to problem 7.1. In problem 7.2, you buy a 7% coupon 20-year bond today when issued. And if interest rates rise to 15%, what happens to the value of your bond? And that is our question. Again, we're going to use the bond valuation formula. There's only one formula. Price of the bond is present value of the coupon plus present value of the face. C times 1 minus 1 over 1 plus R to the T, all of that over R, plus FV over 1 plus R to the T. So you have a 7% coupon 20-year bond that you're holding, so that one is paying off $70 in coupon. All of a sudden, interest rates go up. All of the bonds in the market are now requiring 15% or $150 coupon. What happens to the value of your bond that you're holding? Well, the bond value goes down. As interest rates now, investors now require 15%, interest rates go up, and required returns go up, bond values go down. And it's simply in the mathematics. Basically what's happening here in the math is you're dividing by a larger R. All other bonds in the market are requiring higher rates. Your coupon rate, which is coupon divided by face value, is still at 7%. It's always going to pay $70 for the 20 years you're holding the bond. Now investors are requiring $150 on all other bonds in the market, so the price of your bond will get down and you'll have a discount bond. If you want to, you can prove that by simply putting some numbers into this problem and seeing what happens to the price of the bond. It's all in the mathematics. That's the answer to 7.2. In problem 7.3, we have a German company with bonds that have a 5.8% coupon rate on the market with 23 years time to maturity. If the yield to maturity is 4.7%, what is the bond price in euros? Pay careful attention to your units here, which are euros. Our equation is the same. There's one equation for bonds in Chapter 7. That's bond price is equal present value of the coupon plus present value of the face, broken into 2 pieces. In Excel, and we can type that into Excel, and I'll go over how to do that quickly. I would suggest you set up one box for the present value of the coupon, add that to the present value of the face, and then sum the 2 together to get the price of the bond or present value of the bond. In Excel, we have functions we can use. So I laid this out. If the givens were in, the numbers were in cell C30 through C35, equal price, we're looking for the price of the bond or present value of the bond, left parenthesis C30, comma C31, C32, C33, C34, C35 times 10, because we'll need to multiply that by 10. And here's the syntax for Excel. The settlement date, we make up a purchase date of 1100. January 1st of the year 2000. Maturity date is 1/1/23, 23 years later, because that's our time to maturity. The coupon rate is 5.8%, so we type in 0.058 or 5.8%. YTM is 4.70%. The face value syntax is $100, even though in the FV part of this equation, we're going to put 1,000 into this Excel cell. If we do it separately in Excel out here, doing the mathematics the longhand way, we're going to put $100 for the syntax for this equal price formula. Coupons per year, 1 is an annual coupon. What is the bond price? So if we're going to type these two formulas into the two Excel boxes over here, I'm going to put C, or my coupon of $58 in that position. 0.047 is my YTM, T is 23. And I should, in doing that, I'll get an answer of 804.94 euros for the present value of the coupons. That's this part of the formula. Present value of the face is 1,000 over 1 plus 0.047 to the 23rd power. I should get 347 and 72 euros. And then when I add those two together, I should come up with a bond price of 1,152.66 euros. Similarly, I can do that using this syntax and come up with a bond price. Again, 1100, 1123, 5.8%, 4.7%, $100, one coupon per year. And again, I should get a price of 1,152.66 euros. And there's your answer to problem 7.3. In problem 7.4, we have a Japanese company with a 3.4% coupon bond with 16 years time to maturity. The bond sells for 91.53, about 91.5% of par of 100,000 yen. What is a YTM? So again, we can attack this two ways. We can type the mathematics into individual cells. So put the present value of the coupon equation in this cell, and put the present value of the face in this cell, add the two together to make sure you're getting the right price of the bond. We're going to be substituting different values for little r in these equations till we hit a bond price that we're looking for. Now, what is the bond price? It's 91.53% of par, par being 100,000 yen. So I take 91.53% of 100,000 and I plug in the target I'm trying to get over in this cell is 91,530 yen. I keep substituting little r's and I change the little r value until I reach a price of bond of 91,530 exactly. So what do I plug in for C? For coupon, we know coupon is in dollars. 3.5%, 3.4% of par, 3.4% of par. So we're going to multiply 0.034 times 100,000. We're going to plug in 3,400 in here in the C value when we're typing in this equation. R, we're going to just change values until we hit 91,530. Now, where do we start guessing? Can we start guessing these values intelligently is the question. What kind of a bond do I have? I end up here with a discount bond because it's selling for less than 100,000 yen. That means that all other bonds in the market must be paying more than my bond, which is paying 3.4%. So I'm going to start at higher rates, 3.5, 3.6, 3.7, 3.8, and so on. And I'm going to stop when I hit 91,530. Same thing in this face value cell. I'm going to put face value of 100,000 or par value of 100,000 yen over 1 plus that guess rate to the 16th power. And I keep on guessing and checking 3.5, 3.6, 3.7, 3.8, 3.9, and so on until I hit 91,530 yen in that cell. And we'll go over what that guess rate is here in a minute. In the Excel function, which are a little bit advanced, I'll type in equal yield in cell C51. Equal yield paren, left paren, C45, C46, C47, comma, C48, comma, C49, comma, C50, comma, right paren. I'm going to type that formula into this cell right here, which will be cell C51. 45, I'm going to put the purchase date or settlement date of 1100. I just make that up. And I set the maturity date as 16 years later, because it's a 16-year TTM bond, so 1116. Annual coupon rate of 3.4%. The bond price is 91,530 yen. Face value of 100,000 yen, face or par value. One coupon a year. No need to do this semi-annual bond stuff because it's an annual bond. I'm only going to get one coupon payment per year. And if I guess and check, keep guessing and checking for these R's, the R we come up with is 4.134105%. 4.134% will get me to a price of bond of 91,530 yen. And again, you can see that my YTM that I calculated is higher than the coupon rate, as it should be, because we have a discount bond. There are your answers to problem 7.4. In problem 7.5, we have Vessery Enterprise with bonds with 8 years time to maturity, selling for 948. These are annual bonds, so no need to do this in the annual bond calculation. YTM is 5.9%. What is the coupon rate? So we're looking for C divided by 1,000 in this case. Bond price in this case is 948. We have a discount bond, so we're going to start guessing at rates, let's see, that are lower than the yield to maturity. All of the bonds in the market must be paying more for our bond to be only selling for 948. So when we start guessing for C, we're going to start at rates that are lower than 5.9%. What's that coupon rate? So again, for bond price, I'm going to plug in 948. For C, I'm basically going to leave that open, and I'm going to start guessing at rates in this cell, and then I'm going to stop when I hit 948, a bond price of 948. Little r, I'm going to type in 0.059, that is a percentage, and T, I'm going to type in 8. Face value on this bond is $1,000. Again, I'll break it into two pieces, and I'll relate these cells back to this cell, and I'll guess at rates. I'll start 5.8, 5.7, 5.6, 5.5, and so on. I will keep guessing until I hit $948. The answer I got was 5.0659%. 5.0659%. That means it would pay a coupon of $50 and about 66 cents. If I plug that into this equation and into this syntax, I should get a bond price of 948. Using the Excel values, function values 1100 will be the purchase date, the maturity date 1108. While yield to maturity 5.9, $100 face again for a $1,000 bond. One coupon per year in this case, and a bond price, discount bond price of $948. The answer 5.06. 5.9% will get me to that bond price of $948. And that's your answer to problem 7.5. In problem 7.6, Squeaker's company has 15-year bonds issued 1 year ago, meaning we have 14 years left, at a coupon rate of 4.1%. Semi-annual payments, key point here. Semi-annual payments, we have to pay attention to that because we'll actually collect our coupons twice per year at half the amount. If the YTM is 4.5%, all of the bonds in the market are requiring 4.5%, what is the bond price? And we can predict what the bond price is going to be based on the relationship between our coupon rate and the yield to maturity required by all other bonds in the market. Bond price, we will then expect to be a discount bond selling for less than $1,000 because our company is only paying, our bond's only paying an annual coupon of $41. All other bonds in the market are requiring $45 on an annual basis. So let's attack it with the one formula. We have present value of the coupons plus present value of the face value, and we're going to do it in Excel. And we're going to, by typing in the mathematics, and we're also going to do it in Excel using the equal price function. We have to remember to go C by 2, so take the coupon in dollars before we put it in here. C dollars divided by 2, R percent divided by 2, and T times 2. We're going to collect our bond coupon payment twice a year. So let's go through the mathematics first. With math, you can do anything, my father said one day. Present value of the coupon. C, we're going to plug in our coupon, but we're going to divide it by 2. So the coupon is $41, so we're going to plug in here 41 divided by 2, or 2050. Our percent is 4.5%, so I need to divide that by 2 also, apples to apples. 4.5% divided by 2 will be placed in here for R, and what is that, 2.25, 0.0225 in each of those cases. T, we're going to plug in not 14 times 2, and not 15, because it's issued 1 year ago. 14 years left times 2, we're going to plug in 28. We're going to plug in 1,000 for FE, as usual, unless otherwise instructed. Again, I would break these into 2 pieces, so present value of the coupon comes out, which is the first part of this formula. It should come out to $422.46. Present value of the face, which would be 1,000 over 1.0225 to the T power of 28, should come out to 536.32. When you add those 2 together, that'll give us the price of our bond today, and that is $958.78. Similarly, if I use the price function in cell C, 30, 31, 32, 33, 34, 35, 36, again times 10, I'm going to put 1100 as the buy date, 1114, which is 14 years later, because there are 14 years left, as a maturity date, 4.1% for the coupon rate, 4.5% for the yield to maturity. 100, again, is the syntax for face value rather than 1,000. So if I use the price function, I need to put $100 in there rather than 1,000. And coupons per year, 2, because we have semi-annual payments. Again, I should get the same answer as I got before using the Excel mathematics, 958.78 is your answer to problem number 6. In problem 7, we see that Higginbotham Corp. has issued 20-year bonds 2 years ago, means 18 years left. Coupon rate is 5.3%. Semi-annual payments. Keywords, I must go and when I'm inserting the numbers into the equation, I must go C divided by 2, R divided by 2, and T times 2. Bond sells for 105% of par, so it's more than $1,000. And what is the YTM is the question. So what is the little r is the variable we're looking for. Again, can we guess smartly? Students will say we need to plug and chug to find those 3 R's, and you have to substitute those things simultaneously until you get to the proper bond price, and that's when you know you've hit the right answer. So first we're going to do the bond equation. We're going to guess and check, and where do we start guessing? Bond sells for 105% of par. 105% of 1,000, so we're going to enter a bond price, we're going to target a bond price of $10.50. That's what we want to ultimately end up there in that cell. And we'll keep changing the little r's until we hit $10.50. It's a premium bond. What does that mean? That means that my coupon rate is higher than the yield to maturity, all other bonds in the market. So when I start guessing in this cell for little r, both of these cells, I'm going to guess numbers that are lower than 5.3%. I'll start 5.2, 5.1, 5.0, 4.9, 4.8, and so on, and I'll stop when I hit 10.50, which is my target bond price. Again, premium bond. So that means that my coupon is higher than all other bonds in the market, what they're paying. So C, I'm going to type in $53 normally, but I must divide by 2. 26.50 is what I'll put in here for C. R, I'm going to guess, and it'll be lower than half of that. Lower than 0.0265 is what I'll start plugging in these equations, and I'll stop when I hit 10.50. T, I'm going to plug in 18 years, but 18 times 2. I must go T times 2, so I'm going to put in 36 when I'm plugging in T. And for face value, I'm going to put in 1,000. Again, I'll keep changing those R's, and I'll keep guessing and checking those R's till I hit 10.50. Now, what is that R? The second way we can calculate that in kind of advanced mode is using the equal yield function in Excel. Equal yield, left paren, C45, 46, C47, C48, 49, 50 included in these cells. And in C51, we would put in the YTM guesses, and we would stop when we get to 1050 there. But using this syntax, this will calculate automatically for you, so it's much more efficient. Settlement date 1100, I just make that up. I select the maturity date 18 years later, so 1118. The annual coupon rate is 5.3%. The bond price is $10.50. We said 105% of par. Face value is $100, not $1,000 again, and the $10.50 breaks down to 105. So I put in 105 here because the syntax for the face value is 100 on a $1,000 bond. I divide it basically by 10. 2 coupons per year because we have a semi-annual payment scheme, and we get a final answer for problem number 7 of 4.8794%. And that checks with our thinking. The yield on all other bonds in the market is less than what our bond is paying because we have a premium bond. And that is the number of 0.048794 that I would be guessing for our actually half that when I'm typing it into the formula, because semi-annual, then I come back and multiply it by 2. 4.8794% is your answer to problem number 7. In problem 7.8, we have DMA Corp with bonds of with 14.5 years left, time to maturity, yield to maturity of 5.3%, and a bond price today of $965. That is my present value bond. Semi-annual payments, keywords here. So I must do these calculations when I'm plugging the numbers into this formula. C by 2, R by 2, T times 2. They want to know what is the coupon rate, or C divided by 1,000. So what I'm going to do, again, set up 2 separate Excel cells, one to calculate present value of the coupon and another to calculate present value of the face, and then sum those 2 together to get the bond price. So bond price is a discount bond of $965. What does that mean? That means that my coupon rate is going to be less than all other bonds on the market, yield to maturity, what they're paying. So I'm going to plug in 965 or target 965 in this box here, such that when I add these 2 cells together, I get 965, and I'm going to keep guessing at this coupon rate until this cell and this cell add up to 965. So C is going to be what I'm going to be plugging into this cell. Little r is 0.053, but I must remember to divide that by 2. So when I'm plugging r in to this equation, I'm going to put 0.0265 into each of these 3 places. T will be 14.5 times 2. Again, semi-annual payments. 14.5 times 2 is 29. So when I plug in T in these 2 spots in these 2 cells, I'm going to put in 29. Face value will be $1,000. I keep guessing and guessing and checking, and the answer I come up with, such that the answer I get for coupon rate, such that I hit my 965, is 4.95, 107%. That's my answer for coupon rate, and that's what exactly what the author is looking for. Note that my coupon rate on my bond is less than what all other bonds in the market, hence giving me a bond value of 965, and that being a discount bond. That's your answer to problem 7.8. In problem 7.9, we have a 0 coupon bond, which is great news for us. They're fun problems to do, with a par value of $10,000 and 17 years time to maturity. The YTM is 4.9%, semi-annual payments again, so we have to be careful again with this. And we're going to go C by 2, R by 2, T times 2. What is the price of the bond? So a couple differences here. It's a 0 coupon bond, which means that C is 0. That's terrific news. Par value is $10,000 instead of $1,000, so we're being told differently. So in this case, we're going to put in $10,000 for face value, par value, and 17 years TTM. Again, we got to go T times 2. We're going to make that 34. The yield to maturity, little r, is 4.9, so we're going to divide that by 2. R by 2, we're going to make that 2.45% when we plug that in to the mathematics. What is the price of the bond? So we're looking for present value of the bond or the bond price. Again, break it into 2 pieces, present value of the coupon plus present value of the face. I'd recommend when you type those formulas into these cells here, that you do them one at a time. Do the present value of the coupon in this cell, and then do the present value of the face FV over 1 plus R to the T in this cell, and then add them together to get the price of the bond. So, going left to right, top to bottom, this is X, we're looking for the bond price, we're going to plug in 0 for C. So this whole big mess in the middle goes away. So, since C is 0, our present value of our coupons, present value of that annuity is going to be $0. And then I'm going to plug in face value, in this case 10,000 over 1.0245, 4.9 divided by 2. And we're going to take that to the 34th power, which is 17 times 2, because we have semi-annual bonds. Doing that, we should get a present value of the face value of $43.91 and 30 cents. And total price of the bond then is $43.91.30, because there is no present value of the coupon. If we want to use the equal price function in Excel, we say equal price C 122, and again, I'm assuming these are cells 122, 23, 24, 25, 26, 27. I'm going to put my answer in cell C 128. Buy date is 1100. It's when we settle on the bond. Maturity date 17 years later, 1117. Annual coupon 0.00%. It's a 0 coupon bond. Yield to maturity 4.9%. $1,000 face value. The syntax used to be 100, but now we have to multiply that by 10 because we have a $10,000 bond instead of a $1,000 bond. So our face value we're going to plug in at 1,000. Coupons per year, 2 per year. We should get the same answer that we got when we did the mathematics in the various Excel cells, 43.91 and 30 cents. And there's your answer to problem 7.9. In problem 7.10, we have that Yanyan Corp has a $2,000 par value bond. So again, we're being told a different bond par value. Coupon rate of 4.9% and 13 years time to maturity. The yield to maturity is 3.8%, semi-annual payments. Again, it's critical. So I must do C by 2, R by 2, T times 2 when I enter in the mathematics into the equation. What is the price of the bond today, or a present value of the bond? Bond price again is present value of the coupons plus present value of the face. Using that mathematics, we'll break it into 2 pieces. We'll first do the present value of the coupon in one cell, present value of the face in another cell, and add them together. Now, what kind of a bond might we predict? What kind of a price might we predict? Will it be more than $2,000 for today's bond price or less? Well, our coupon is paying $49 per year, 4.9%, times 2, so that'd be $98. All other bonds in the market are only paying 3.8%. They're paying less than what our bond is paying. So we might expect a bond price here greater than $2,000 because our bond is paying more than all other bonds in the market. So going through the mathematics, bond price equal to C, coupon. So I'm going to take $49 and divide by 2 and enter that into the C slot. 49 divided by 2, $24.50 I'm going to put in here. R, I'm going to take R by 2 because semi-annual coupon bonds we must keep coupon rates and required rate of return in sync. So 3.8% divided by 2.019, I'm going to plug in for R in 3 places, 1.9%. T will be multiplied by 2, so it's 13 years. I'm going to plug in 26 into the T slot here. And here for FV, I'm going to plug in 2,000 instead of 1,000. We have to be careful there. It's always 1,000 on corporate bonds unless otherwise told. In this case, we're otherwise told we're going to plug in 2,000. Anyway, if I do the math here, the present value of the coupon, which is the first part of that formula, will give me 998.01. And the second value, when I take 2,000 over 1.019 to the 26th power, I get 1226.03. Add the 2 pieces together, and I get an ending bond price of $2,224.04. And as we predicted, a higher than par value bond. We have a premium bond because our coupon rate is higher than all other bonds in the market. Settlement date, we purchase a bond on 1100. It matures 13 years later on 1113. The annual coupon rate is 4.9%. The yield to maturity, I plug in 3.8% or 0.038. Face value $200. Normally I was putting in 100 in the syntax for a $1,000 bond. Now for a $2,000 bond, I'm putting in $200. That's just the syntax that Excel requires. Coupons per year are 2, and if I do this mathematics, and then this cell down here in cell C143, I type equal price C137, comma C138, comma C139, comma 140, 141, 142, paren times 10, I get a bond price of $22.24 and 4 cents, as I did before. Here's our answer to problem 7.10. In problem 7.11, we have union local school districts. So school districts issue bonds also. If your high school is putting up a new building, or new buildings, oftentimes they will float a bond. Union's bond is selling for $5,000 par value, face value, with a coupon rate of 3.7% and 16 years time to maturity. Yield to maturity is 3.9%. Now let's take a look and predict what this price is going to be. Your bond is paying 3.7%. All other bonds in the market are requiring 3.9%. Turns out you should expect a discount bond when it's all said and done, so something less than $5,000. Bond price is equal to present value of the annuity or the coupons plus present value of the face. Again, I have to go C by 2, R by 2, T times 2, because it does say semi-annual bonds in this case. So let's do the 2 cells. So I'm going to put the answer to this part, the present value of the coupons in this cell, present value of the face in this cell, and then total them up. So I'm going to plug in for C, my coupon in dollars. I got to go C by 2. So I must go $37 divided by 2, or $18.50 each time. I'm going to plug in $18.50 here, because we all know that coupon is in dollars. Yield to maturity is 3.9%. I got to go R by 2, so I got to go $39 divided by 2, or 0.0195. I'm going to put percent in there, 0.0195%, 0.0195, 0.0195. Face value, this time I'm putting in $5,000. It's a $5,000 par value bond. And T, I'm going to put 16 years divided by 2, because I have to go in twice. I'm sorry, T times 2, I'm going T times 2, twice a year, so 16 times 2. I had it right in my first thought. So 16 times 2, I'm going to plug in 32. Let's review again. C, I'm going to put in coupon of $37 divided by 2, $18.50. R, I'm going to put in 0.039 divided by 2, or 0.0195 in each case. T, I'm going to put in 32, 16 times 2. Face value is going to be $5,000. If I do that math, I get a present value of the coupons, first part of the equation, of $21.8668. Present value of the face, which is this part, $26.9512, and I get a discount bond, which is selling for less than $5,000, $4,881.80. If I use the Excel function, equal price, paren C153, comma C154, 155, 156, 157, 158, in cell 159, I'm going to put that formula down here. In 153, I put the settlement date 1100. The maturity date is 1116. The annual coupon 3.7%. The YTM 3.9%. $500 I put in for the syntax for the face value. Normally that's 100, but since it's a $5,000 bond, I multiply that by 5. 2 coupons per year, and I should get the same answer. I should get $4,881.80 when it's all said and done. That's your answer to problem number 11. In problem 7.12, we're given that T-bills pay 5.1%, inflation is 2.2%, find little r. And our equation for the approximate Fisher effect is big R, or total return equals approximately little r plus little h. The exact Fisher effect says 1 plus the nominal rate, or total rate, equals 1 plus little r times 1 plus h. So let's do the approximate in our head, and let's do the exact using this second equation. So using approximate Fisher effect, 0.051 is our big R, 0.022 is little r, and h, and then r is r. So we're solving for r. 0.051 minus 0.022, we get 2.9% as an approximation. So our final exact answer for r should be close to that. So I plug into this equation, 1 plus 0.051 equals 1 plus r times 1 plus 0.022, h being 2.2%, and I get an exact Fisher effect of 2.8376%. There's your exact Fisher effect answer. That should be very close to your approximation that you did in your head. There's your answers to problem number 12. In problem 713, we have a real rate little r of 1.9% and inflation h of 3.1. They want you to find the big R, or total or nominal return. It's simply equal to little r plus little h. So I take 0.019 plus 0.031, and I get an approximation of 0.050, or big R of 5.0%. And there's my answer approximately. Now I should get something when I plug these into the exact Fisher effect. 1 plus 0.019 times 1 plus 0.031 should equal 1 plus big R, and therefore when I do the math, big R equals exactly 5.06%. There's your answer, and it should be very, very close to our approximation. There's your answer to problem number 13. In problem number 14, we're given that Janice Yellen says the real rate of return is 9%, an investment you have offers a return of 11.5%, the total return. What is H? What is the inflation rate? Again, big R equals little r plus little h approximately. So 11.5 equals approximately 0.09 of real plus some h. We do the calculation, we get an h of 2.5% approximately, approximate h. The exact h is 1 plus nominal, 1 plus total, 1 plus 11.5, equals 1.09 times 1 plus h. And in this case, we get an h of 2.29%, which is very close to our approximation of 2.5% on the Fisher effect. There are your answers to problem number 14. On problem number 15, we're given that our total return is 11.65%. Inflation is 3.4%. What is real rate of return little r? Using approximate Fisher effect, big R equals little r plus h, and exact Fisher, 1 plus big R, or nominal return, equals 1 plus little r times 1 plus h. So the approximation we want to target is we're going to put in 11.65 here, we're going to put in 0.034 for h, and I get an r using a simple subtraction of 8.25%. So our answer should be somewhere near 8.25 when we slide it back into the exact Fisher effect. 1 plus 0.1165 equals 1 plus 0.034 for inflation times 1 plus r. I'm solving for r here, and I should get an r in exact fashion of 7.98%, which we find is very close to our approximation we did in our head of 8.25%. There's your answer to problem number 15.